Hi and welcome to video 6 of our series on anti-differentiation, and in this video we're going to introduce exponential functions and how that looks under the rules of integration. So first of all, we know that dy dx of e to the x equals e to the x, and therefore the integral of e to the x dx equals e to the x plus c. And we also know that the derivative of e to the kx equals e to the kx. Remember the exponential doesn't change, but we just have another multiple of k, which didn't look very good there. Let's try that again, k. And so the integral of e to the kx dx is equal to e to the kx, but this time we have to divide by k, just to eliminate that k for when we redifferentiate to get the same result. And of course you get similar results here. The b doesn't really affect anything, it stays in the power. Constant is like the constant we've been dealing with in previous exercises. So this is quite nice and quite easy, and probably easier than polynomials really. So example 8, determine the integral of e to the 2x dx, and of course the answer to this is a half e to the 2x plus c. And then question B, if dy dx equals 2e to the half x and y equals 3 when x equals 0, determine y in terms of x. So this is a particular solution question, and we know our value of dy dx, and therefore y is equal to the integral of 2e to the half x dx with some known values there. And when I integrate that, I get 2e to the half x divided by a half plus c, and that's equal to 4e to the half x. And I've got a plus c there, and of course I know that when y equals 3, x equals 0, and so I get 3 is equal to 4e to the half times 0 plus c. 3 is equal to 4e to the 0, which is 4 times 1, so just 4 plus c, and therefore c is equal to -1, and that means that y is equal to 4e to the power of a half x minus 1 is my particular solution because I've worked out the value of my constant. Okay, now we're on to example 9, and this is a complex familiar question. So by first calculating d dx of x minus 1 e to the x, we're going to determine the equation of the curve y equals f of x, where the gradient function is dy dx equals x e to the x, and the curve passes through that particular point. So first of all, this is kind of like a part A, part B question. And part A, we're asked to derive something which looks a little bit like what we're asked to integrate in part B. So there's probably going to be a connection between them. Secondly, we're asked to find a particular solution because we know a known coordinate. And thirdly, we're asked to determine the equation of a curve here, so that's where that integration is going to come in. We're trying to find the equation of that particular curve. We're going to have to rely on a few different skills, which we'll get to in a minute, and this could be broached into a complex unfamiliar by maybe making this function a little bit less linked to the function in part B, or perhaps by then taking it a step further by asking something about the curve's intercept, or where the curve meets another curve, or something like that. So you'll see complex unfamiliar will often rely on multiple elements. But anyway, this is down as a complex familiar. So let's follow through the process. First of all, in part A, we're asked to determine d dx of x minus 1 e to the x. And hopefully you'll recognize that this is a product rule, and so it's going to be equal to u dash v plus v dash u, where u is equal to x minus 1 and v is equal to e to the x, and therefore u dash is equal to 1 and v dash is equal to e to the x. And of course this means that u dash v is just e to the x, and v dash u is e to the x times x minus 1. And so when I expand this, I get e to the x plus x e to the x minus e to the x, and that of course gives me, they cancel out, just gives me x e to the x. So that's worked out quite nicely for me. And part B states that dy dx is equal to x e to the x with a known coordinate, and that means that y is equal to the integral of x e to the x dx, which we now know to be x minus 1, e to the x plus some constant. And we also know the curve passes through 1, e, so at x equals 1, y equals e, and so we get e is equal to 1 minus 1 e to the x plus c. 1 minus 1 is 0, and so 0 times e to the x is 0, and so that shouldn't even be e to the x, that should be e to the 1. And we get c is equal to e, which gives us y is equal to x minus 1 e to the x plus e. And e is, of course, just some number. And we go back to the question, determine the equation of the curve that, where the gradient function, blah, blah, blah. Determine the equation of the function, and of course, there it is. So there we have working with exponential functions and a couple of examples. All the best.